Hello. I wanted to introduce you to a site. This is a really cool place. This person has developed all kinds of interactive models of different scientific processes. Trying to think, let's see what there is here. Metabolism, the one we're in, cellular respiration, there's one for photosynthesis. So when he has the accounting model, he's counting. He's like keeping up with different amounts of the molecules required and produced. So I'll have this as a link on your sheet that you can pull up that will be part of our Zoom that we work with. But what I want to do is I want to walk you through how to use it, and just, I don't know, I guess what I'm trying to say is to help you think through why he has the different toggles over here, and then you could just play around with them and how to take some notes on that. Because what I'll do is I'll have some screen captures with different information and questions, and that'll be what you'll do as your Zoom assignment for next week. So playing around with this is really going to help you with understanding. You can go back over to these other tabs. This is where he walks you through, and he just says it's a model, it's computational, which means it's going to give you quantitative data, numbers, and as you change things, and it helps you to see the relationship of if you have changes in one type of precursor molecule or some condition and how it affects everything else. Then he just walks you through these processes. So glycolysis, we talked about that. That's the very first step in cellular respiration. It's anaerobic. It runs whether there's oxygen or not. It is not about making ATP. It only has 2 net, and so that's not its job. Its job is that it prepares glucose by snapping it in half into 2 pyruvates. Fermentation is what we call the process where that we went through glycolysis, but without oxygen, we don't have the ability to further metabolize pyruvate into just electrons for the electron transport chain. So you have to go through another kind of like a hack is what happens. So the electrons from NADH are given to pyruvate. Pyruvate becomes reduced into lactate, and then that allows the process of glycolysis to continue, and that's what's called lactic acid fermentation. Some organisms like yeast, they do alcoholic or ethanol-based fermentation where the molecule produced from reducing pyruvate is ethanol. So this all occurs in the cytoplasm. They say cytosol, it doesn't really matter. And then if you have oxygen, you can do the rest of the breakdown of glucose. So you take your pyruvate, you generate acetyl, and then you have acetyl-CoA that goes into the citric acid cycle, which is the same thing as Krebs. And then once you do that, Krebs is like a disposol. It just chews up 2 carbon pieces and gives you electrons that run through the electron transport chain as carried by NADH and FADH2. So they show you, where this works. Don't get confused with this electron transport chain here and him showing that you have electrons being dropped off or taken away. NADH goes to complex 1, and Q pulls the electrons away, which allows there to be hydrogen ions pumped here. But this is for FADH2. He doesn't really tell you that. He calls it fumarate, but it's the same thing. And obviously when you skip this first complex, because this is where FADH2 parks is complex 2, you have less hydrogen ions pumped, which means fewer ATP because you skip this first pump. So he shows you those pieces. That's what he calls his introduction. Then for the background, this is a really nice summary of cellular respiration. It's short, it's to the point, it's a really good brief way to make sure that it makes sense to your head. Then he takes all this different pieces of information and he builds out a simulation. So what he has set as his default, which you come back here and click reset and it'll take it to the default. Let's look at what he's set it up as. You have plenty of oxygen, so oxygen's not limited. The pH he has set at 7, which is neutral. That's not physiological, but that's what he set it at. You did not have any NADH, so you don't have any of the reduced form of this electron carrier initially. And it looks weird with the temperature set at 37, but 37 is body temperature in Celsius. And so he's purposefully set this at body temperature. Physiological would be more like 7.3, but he's left it at neutral. And then what you're really doing is, I don't have any ATP to begin with. I don't have any electron carriers to begin with. All I have is glucose. So what happens if I press the button and we metabolize that 1 mole of glucose? You push the green button and it's messy. He puts all of the graphs together in this metabolism. Makes much more sense if you come over here and click them individually. So these would be, these tabs, these would be things that could be measured in a lab experiment, something where you could collect data in order to determine the rate of cellular respiration. The most common one that we would use, and it would be in a test question, would be the oxygen that's consumed, because they link that to metabolism. So if you have a very high rate of cellular respiration, you would also consume a lot of oxygen. So they link those. But let's just look at these individually. So the very first graph he's got is, if you have just 1 mole of glucose, how many ATP will you make? And if you look, this is over time. So you start off with, and down here it's kind of hard to see the scale, but that's 2. So you have 2 net that you've made, and then you have 4 total at this point. So you want to think about what process would be occurring here where you've only made 2. And then as you move on, where are you here in cellular respiration where you only have 4? And then you very quickly create around 34-ish ATP, 36-ish, I guess, on here total, and then it stays constant because that's all you can get from 1 mole of glucose. So think about where you are in cellular respiration for each one of these pieces. That's the kind of question I'm going to ask you. And then how much oxygen was consumed? Well, initially you didn't use any. Why would that be? And then over time you consumed oxygen, and then you didn't need to consume any more because you were through with actually doing cellular respiration because you ran out of glucose. So at this point, this would be your new baseline if you started and kept going. So what about electrons? That's what NADH is about. Do you have electrons being created? So initially, you don't have any electrons that are being lost or released from bonds being broken in glucose. Then you have, looks like, I guess that's 2, and then you're at 4, and then you're at 10 NADH. Every NADH has 2 electrons, and then here's where you've got these, now you've got 10 electron carriers of NADH, and then what's going on here where all of a sudden you don't have any more NADH. Now, the thing I think that's the most confusing for students is when you metabolize something, you don't necessarily lose it, like it's not just magically gone. In this particular case right here, where you have 10 NADH, this value here, and then as that drops, it's not that you have nothing down here. What you would have would be NAD. So NAD would be the form that would be down here, where that it's the oxidized form, where the electrons have been removed from NADH. Don't worry about this one. We'll get to that a little bit later. That's potential over a membrane, and we won't do that for a little while. So then play around with some of this stuff. So for example, I'm just going to go extreme. Okay, let me just say this. I should have said this. It keeps your runs. So run 1 was a default. And so here's what I think I would do. Now this is me. You do you, whatever. I would come over here and I would, because you do need to have a place in your notebook, because I'm going to tell you you can use your notebook. So this is that, what's it called? Jon Darkow. And I'm not going to write cellular respiration. And this is his simulation. So what I would do is I would keep up with my runs. So at run 1, I had what conditions? I had 100% oxygen. I had a pH of 7. I had no NADH. I was at a physiological, so that's body temperature, BT. You can't see what I'm writing. Okay, I'll show you in a second. You had 1 mole of glucose, and you had no ATP. Okay, so this is what I wrote. I just copied down here. So this is what the conditions were for run 1. And then you could come over here and write what, since this is run 1, these are your settings. What did you notice as far as the simulation once it ran? Okay, so what we saw was, I've got the clicks up at the top. I'm going to focus on ATP being made, oxygen being consumed, and NADH electron being made. So for ATP, so I'm going to come over here for the ATP part. I'm just going to follow a little thing here. I had 2, and then I had 4, and then I had about 36-ish. So here's what I did. I just gave myself this, here's the pattern as far as what happened over time. Let's keep on going. What did my oxygen consumption look like? So for oxygen, I had 100%, and I ended up using some. And it was later. You could even do that as far as tell when. So then I'm going to do the same thing here for NADH. The default was I started with 0, then I had 2, then I had 4, then I had 10, and then I had none. So that's just me keeping up with what's going on. Then I'm going to run it again, and I'm going to just put what I changed. I'm only going to change one thing. So in this one, I don't know, let's just have 0% oxygen. Let's change that. And it's going to leave my run 1 so I can see what the difference was. So I'm going to go here and change it to 0. I'm going to run it. And now I'm going to be able to see the difference in what was done, that was really messy. And so here's what happens with my ATP. I had 0, then I had 2, and I never made more than 2. So I'll come back over here to what happened to my graph. 0, and then I had 2, and that's it. What happens with my oxygen? It stayed the same. So your oxygen consumption, you had 100%, and then you used the same amount as before. And for NADH, I had electrons that were, first I didn't have any because that's the default. Then I had some electrons created, so I had 2, and then I have none. And see how that I'm here at run 2. So what I would do, this is me, I would go, okay, I've messed with this one. I'm going to put it back to where the default is. Let me think about what pH means in this intermembrane space. So let's think about that. Here's the intermembrane space. I've called it a closet that only holds hydrogen ions. pH is a measure of the concentration of hydrogen ions. So let's write ourselves a little note over here, because I'm going to change pH next. So this is run 3. And I'm going to write myself a little note here. pH is equal to the concentration of hydrogen ions. That's what it is. And we're looking in that intermembrane space, which is where we keep the hydrogen ions. So one of the things that's really important as you write, they're always wanting you to demonstrate that you understand about relationships. So as the pH decreases, so when you have a decrease in pH, so maybe I go from 7 to 6, I have an increase in the hydrogen ion concentration. So lower pHs have more hydrogen ions. Well, you need to think about how that would work. Like, what do we use the hydrogen ions for in that intermembrane space? And what would having more of them do? And if I increase the pH, maybe I go from 7 to 8, I'll decrease the concentration of hydrogen ions. So this is just something for me to remember. All right, so I'm going to change my pH to 6, and then I'm going to turn around and I'm going to do it again and run it at 8. Okay? No crazy extremes. Enzymes can't handle big, huge changes in pH and still function. So I've got my resets. Don't go down here and reset it. You'll lose your runs. So I'm leaving everything. I put my oxygen the way I found it. So now I'm going to change the pH to 6. Leave everything the same. And I'm going to run. So I'll go back up here and see what happened. Okay, so this is this purple. So I'm going to write myself my notes. So for ATP, I did not have this 0 and then 2. I had not a really linear thing, but I had, I'm just going to put an increase from, what was that, 0 to 50, and then a rapid increase from 50 to 80, and then an increase from 80 to about 110. I don't know. None of that matters. Okay, so here's what that looks like on my notes. I just said that there was an increase, which to me means positive slope initially that went from 0 to 50. At 50, that slope was steeper until I hit 80, and then the slope was not as steep. So now I'm going to go and I'm going to run it with a pH of 8. So I have less hydrogen ions. Let's see what that does. Now, let's go back. I didn't do, but now see, it saved it all. That's okay. So we'll do it all at once. So run 4 is this green one. So initially, I didn't have hardly any, so I'll put over here for the ATP. I had basically nothing. Well, I went from 0 to 2. Right? No, is that 2? I can't read that. The scale's not good. So I went from 0 to maybe 10, 8. 0 to maybe 8, 10. And that was where I stayed. So I forgot to check my oxygen consumption. So it looks like that the oxygen consumption did not change when I increased or when I decreased. When I have the pH at 6, that's run 3. So there's no change. But when I increased the pH to 8, it took longer for you to start consuming oxygen. And let's see what happened to the NADH. So for run 3, there's no change. So when you give it more hydrogen ions, it didn't give you a different pattern in your NADH. And the same thing happened again here when I had less hydrogen ions, a higher pH. It's the exact same pattern, but it's delayed. So I'll write that again. So NADH took longer. Now, you want to be more mathematical. You can just put that there's a shift to the right, and it looks like the shift is probably, I don't know, a shift of maybe 1 millisecond, but there's a shift to the right. Okay, do you get the idea what I'm doing? Like, I don't want to keep doing these. I just want to show you what I'm doing. So here's what my paper looks like. And I haven't written anything in there about what I think the reasoning for this is. I'm just detailing what I saw. So I would do another run with all the rest of them. I would keep everything set to the default, except the next time I would see what happens if I have a bunch of NADH. I think you can go up to 40 moles. Put that in there. Change your temperature. Change your glucose. Change your amount of ATP at the beginning. Get a feel for what's going on. And then in a different color, so here, when I have 0% oxygen, I'm going to remind myself that this is for anaerobic conditions because there's no oxygen available. And then I'm going to start thinking about this part. So when you're anaerobic, cellular respiration stops. It only goes through glycolysis. So you're going to only have glycolysis, and glycolysis in anaerobic conditions is called fermentation. So in glycolysis, we have 2 net ATP. So that makes sense, okay? So all of these 2 ATP are going to come from glycolysis only, because everything else after that, pyruvate oxidation, everything that moves into the mitochondria requires oxygen. So we had a decrease in oxygen. That's really interesting. Like, you need to think about why that would happen, right? So here, let's look at that again. So I'm going to start over because I want to just see that one part. So if I start with none and I run it, it's flat. That wasn't what we had before. So I'm going to fix that because that's important. So I have 0% and I stayed at 0%. Maybe I just didn't see it because it was flat. My brain told me that that didn't make any sense. So I've corrected that right there. So NADH, I created 2, but then they're gone. This is the most important conversation. So where did you make your NADH? Well, in anaerobic conditions, we're only doing glycolysis. So this is made in glycolysis. So these are the 2 right here are glycolysis only, which really it's fermentation, but same thing, except in anaerobic conditions we're going to call glycolysis fermentation. But why did we go to 0? Like, where'd they go? I don't know if I can find it. Give me 2 seconds. And by that I don't mean 2 seconds. But let me look in through here in my notes and tell you where to go read. Because this is absolutely one of their favorite questions to ask you. Just toward the end. All right, here we go. So 9.5, number 2. Consider this NADH that's formed during glycolysis. That's right where we are in the simulation. What is the final acceptor for its electrons? Well, normally its electrons are going to be given to Q, to C, and then finally to oxygen. Oh, that's right though. Just kidding. We're anaerobic right now, aren't we? So during fermentation, which would be anaerobic, they give them to pyruvate. If you don't really understand this whole piece, I would go back and watch the notes. You can go to YouTube. YouTube has its, our channel is DBHSAP Bio. So you can go there. And we just said that was 9.5, number 2. Yes. So I'm going to tell you to use 9.5, number 2 to explain this pattern. So those are the kind of questions that you're going to have. So, you know, being able to have this populated, you should be able to flip really quickly to answer the questions that I'm going to ask you, which will just be screenshots from this simulation, and ask you to explain what the measurements are like. Why did we get the graph we got? Okay? So that's what I would do. I would just keep changing some things in the simulation, play around with it, feel comfortable with it, and then know that the Zoom is going to be the same as the way we did it this week. I will bring you in, I'll have a document, and you'll use the document, and then you will have a scoring rubric the same kind of way, where that you'll answer questions about different screenshots. Okay, and then that way we should be done with cellular respiration at that point. So the last half of the week we'll be starting the notes next week, before, because you know we're coming back. I told you this yesterday. We're coming back our 3rd week after Martin Luther King Day in a hybrid model. So you'll have the 2 days you're in here with me, we'll do hands-on kind of lab things. And then the 2 days that you're at home, you'll do notes by video. And so we'll keep it up that way and see how things go. So anyway, I'm trying to fight with my chair so I can squiggle out of here. So you're wonderful. Thank you. Go play around with this. I'll put the site in Edpuzzle. Like I'll put the URL for where you go. But if you just Google this, you'll be able to find it. Okay, you're the best.